So it's a quadratic elongation we have completed. It is important. Angular shear strain, say tau. In this is undeformed body. When deformed in an angular rotation, this is the angle tau. Okay, and if the angle tau is negative, then it is dextral. Tau is negative. I don't know how. It should be positive. If the line has moved clockwise, so it is written that if the tau is negative, then it will be dextral. If it is positive, then it will be sinistral. Next is shear strain. Y equal to 10, the amount of the angle. Okay, if y could be the positive, negative according to the tau value. In order to discuss strain at a single point, changes in the angle between pair of lines are essential along the changes in the length of these lines. So shear strain, it is the amount of the angle. So 10 of that amount, 10 of that amount. Okay, then as we have the natural strain. What is natural strain? It is natural logarithm of E equal to log E 1 plus E. Natural, this is the natural logarithm of elongations. Natural logarithms of elongation, natural logarithm of elongations. E equal to log E 1 plus A equal to log E 1 plus A equal to log E 1 plus E. Okay. Then these are important measures for if the analysis of strain is in two dimensions. The principal extension direction is denoted by E1 and the principal shortening direction is by E2. However, E3 is denoted to third in case of 3D. E1, E2 and E3 are negative and then implies the volume loss. If E1, E2 are positive, volume increase. If one is positive, one is constrictional. If one is positive, it is elongated. Symmetrical extension, symmetrical shortening, axial extension, axial shortening, known as flattening. And one is negative, second and third is zero, which is plane strain. Okay, and with the analysis of deformation. So we know that principal axis of strain is are parallel to the quadratic elongation direction u lambda 1, lambda 2 and lambda 3. Then magnitude are this root over directly root over of lambda 1 is the magnitude. This is the direction, this is the magnitude. If the analysis in the analysis of strain in 2D, the principal extension direction is designated by lambda 1 and principal shortening direction. In the analysis of 2D, yes, in 2D we have only two direction and these are lambda 1 and lambda 2. But in 3D, all the three lambda 1, lambda 2 and lambda 3 are if lambda 1, lambda 2 and lambda 3 is greater than 1, it is increase volume increase, less than 1 volume decrease. Okay, if 1 is greater than 1, other is less than 1 and the third is unity, implies plane strain. If 2 is greater than third, it implies flattening, while 2 implies constriction. So it is the last point which we read earlier. Okay, so this was all about the analysis of deformation part 2.